T is the midpoint of PQ. Show that R, M, and T are collinear. If they are collinear, they lie on the same straight line. T is the midpoint of PQ. That is where we will begin. As a matter of fact, we intend to show collinearity by finding two vectors involving these 3 points. And if those two vectors can be shown to be parallel, then the points are collinear. There are other vectors that we found on previous audiovisuals. We'll bring them to the fore in order to show, instead of finding those vectors again. But I am sure that there is at least one that we have not found as yet. T is the midpoint of PQ. It means that since PQ is the vector U, then any vector that is going to go from T to Q or from P to T will be half of that vector. But let's take a look at the finer details. The midpoint divides the line segment and hence the vector into two halves. The midpoint divides the line segment and hence the vector into two halves. PQRS is a parallelogram, which means that PS is equal to QR. The vector that is PS is equal to the vector that is QR. And we are sure that PQ is also equal to SR, but it's not necessary at this point. The vector that we had right here, PS, is the same vector for QR. To prove that the 3 points are collinear, we need two vectors involving these 3 points. And at the moment, we are attempting to find one other vector. For reasons that will be discussed a little bit later, let us find the vector TR. We are going to find the vector TR, the vector that goes from T to R. A half of that vector, which is U, then we will go the entire route from P to Q, which is that vector V. Therefore, TR is equal to a half U plus V. Now, we will write this taking a common factor of a half. If we take out a common factor of a half, it means that each term will be divided by a half. So let us take the common factor of a half. So we will have a half as the common factor, and we have a half of U, which we have right here, and we also have V. In order to take a common factor, we will have to divide each of the terms by the common factor, which is a half. Also, dividing by a half is the same as multiplying by its reciprocal. Now, let us go back. What we have here is the same thing. A half of U plus V. We are taking the common factor of a half out. We divide by a half in each case. Dividing by a half is the same as multiplying by the reciprocal, which is 2, or 2 over 1. What will happen, as you can see right here, as you imagine that if we take the factor of a half away from the U, U is all that we will have left. But as it pertains to the V, we have to be mindful that in order to maintain the integrity, we will have to multiply by 2, which is going to be the consequence of taking the factor of a half as we have it right there. So V will be multiplied by 2. And if we take a look at it this way, a half of U, a half of U. A half of 2V, the 2 will cancel and we will have V. We are 100% sure that that is correct. Now, let us go closer to showing that the points are collinear. Points are collinear if they are lying on the same straight line. T, M, and R are collinear. We may draw a straight line joining all of them. That's what it means by saying that they are collinear. Although it might not be possible in a diagram that is not drawn to scale. This one, not drawn to scale necessarily, but it also shows that they are on the same straight line. To show that T, M, and R are collinear, we need to find two vectors involving the 3 points and show that they are parallel. And I am sure that we just found the other vector on the previous slide, and we have vectors coming over from the previous audiovisual. So the possibilities are, if we're going to find two vectors involving the 3 points, we will have Tm, then Tr, and Mr. Those are the possibilities. Tm, Tr, and Mr. What is also true is if we choose the vectors that go in the opposite direction. The vectors in the opposite direction to those that we have may also be used. Now, we have found two of those vectors already, as we will see. We have two of the vectors already. The two vectors that we have already are Tr, which we found from the previous slide, and Mr, that we found from a previous audiovisual. Mr was required from the statement of the problem, and we choose to find Tr. We need to find Tr, or need to find another vector. Tr is the one that we chose to find in order that we can show that the points are collinear. But Mr was a requirement of the statement of the problem. Now, if we take a look at the vectors that we have inside of the brackets, we realize that they are identical. What we have here are real numbers, which are just multipliers. If we factor out real numbers and the vectors are identical, then the vectors are parallel. So the factor that we have in the brackets, which in each case is a vector, and they are identical, these being real numbers, we are sure that these two vectors are parallel. And since the two vectors are parallel, then we know that the 3 points are collinear. Tr is parallel to Mr. That makes the points T, M, and R collinear. How do we prove that points are collinear? 3 of them. Two vectors involving the 3 points are parallel. Then we are sure that those 3 points are collinear. Also, if one vector is a multiple of the other, then they are parallel. So, having two vectors existing in such a way that when we take out factors, we have identical vectors here. That's one way. And if we can show that one vector is a multiple of the other, then they are parallel. As a matter of fact, because we can take out real number factors and they are identical, we are sure from here that one is a multiple of the other. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.